Hi, and welcome to Backer Breaks It Down. In today's episode, we're going to look at sinusoidal functions and their applications. So you know what that means? Yeah, there are going to be some word problems on here, but that's okay because I'm about to break it down for you. So remember, when we write a sinusoidal function, we want to be like, what's the function? And it's all dependent on our starting point. The y-axis is a good place to look for that starting point. We want it to be a good starting point. We want it to be either at the maximum, minimum, or midline of the function. Okay, and if the y-axis doesn't produce a good starting point, well, okay, we're gonna go off the y-axis, and there's gonna be a horizontal shift, but it's gonna be okay, right? So that selected starting point, if it's at the midline of the graph, you're gonna be writing a sine function. If it's at the maximum or minimum value of the graph, then it's gonna be cosine. Pay attention to whether or not the function has been flipped. And also remember, if you're not on the y-axis, there is a horizontal shift, okay? In problems where you're like, especially word problems, I find the max and minimum values to be particularly helpful in finding the amplitude and the midline. And so that you might find yourself using the amplitude and midline formulas more so with word problems than you did with graphs, okay? But it's fine, it actually makes it easier. The amplitude can be found by going the max minus the min and dividing by 2. The midline can be found by going the max plus the min divided by 2. And then remember the period, if we're talking like a word problem, it's going to be a time interval. Like how long does it take for like one full cycle of the object? That's going to be the period. We are still going to then determine the b value for our function. B is equal to 2 pi divided by the period. Okay. So I want to build us up to the word problem. So I'm going to start with some graphs. Okay. Just, get ourselves comfortable. So here we have a graph. They've identified a few points on the graph for us. And so to write a sinusoidal function, you need to select a starting point. So pick a point that you're feeling like good about. I'm feeling good about the 313 just because it's the first nice point on my graph, so why not? And so based on my selected starting point, this is a cosine function because like it is starting at the minimum value of my graph. It has been flipped because it's starting at the minimum, not the maximum. And I do have a horizontal shift because I'm not on the y-axis, and that shift is to the right 3 units. Now for my amplitude, period, and midline. If I want to go the max-min approach, like the maximum value of my function is 27 and the minimum value is 13. So I can then plug these values into my amplitude and midline formulas to find those two things. So for amplitude, I would go 27 minus 13, and that's 14 divided by 2 is 7. And for my midline, I'm going to go 27 plus 13, and that's 40, and 40 divided by 2 is 20. For the period, I should highlight out one full cycle of cosine. So if cosine starts at its minimum, by the time it returns to its minimum, that's one full cycle. So one full cycle of this graph starts at 3, ends at 15, so that's 12. So the period is 12, which means the b value is 2 pi divided by 12, which is pi over 6. So then I can put all of these pieces together and I can write my sinusoidal function. So I'm going to have y equals, it was flipped, so my amplitude is going to have a negative in front of it, so -7. Next up is my trig function, which is cosine. And then in parentheses, I'm going to have my b value of pi over 6. And following that will be my horizontal shift. So right 3 would be x minus 3. And then I'm going to end this function with my midline of plus 20. So my sinusoidal function for this graph is y equals -7 cosine of pi over 6 times the quantity x minus 3 plus 20. Remember, if you had chosen a different starting point, you might have a sine function. It may or may not have been flipped, and then it may or may not have had a horizontal shift. But the big three stay the same, right? So problem number 2 still isn't really like a true word problem, but they didn't give us a diagram. And so like honestly, diagrams help. They're going to help you kind of like see which sinusoidal function you're working with. Sketches definitely help, okay? So this sinusoid rises from a minimum value at 5 at x equals 0 to a maximum value of 25 at x equals 32, okay? And so like that minimum is starting at 0 and it has like a y value of 5. So there's my starting point. And then it says it gets to a maximum value of 25 at x equals 32. So it's going min to max. Now, what kind of function do you know that goes from its minimum to its maximum like that? Yeah, cosine does. Cosine can totally start at a minimum. When it does, it has been flipped. And we are starting right away on that y-axis, so there's no horizontal shift, okay? Amplitude and midline, the fact that I have, like it was given to me, my max and minimum values, like why not use them to find my amplitude and midline? So amplitude is going to be equal to 25 minus 5, which is 20, divided by 2 is 10. And then the midline, I'll go 25 plus 5, so that's 30, and 30 divided by 2 is 15. Now the period. If you're thinking the period is 32, I want you to think, what does one full cycle of cosine look like? Because that right there is not one full cycle of cosine. Like since this cosine graph started at its minimum, it'll be over when it reaches its minimum again. So if it went from its minimum to its maximum in 32 units, it's going to need another 32 units to finish one cycle. So one full cycle of cosine here is 64. That's something to pay attention to in these problems when you're not given the graph and you're like producing your own sketch. Think about like how much of the graph are you looking at? Are you seeing one full cycle? Or are you seeing less? Okay, pay attention to that. So the period of this function is 64, which means the b value is 2 pi divided by 64, which is pi over 32. So now that I've analyzed this function, I am ready to write the function formula. So I'm going to have y equals, we said it was flipped, so I'm going to start it out with a -10. We are working with cosine. Next is our b value of pi over 32. There is no horizontal shift, so I'm just going to attach the x there and then add on my midline. So I have y equals -10 cosine of pi over 32x plus 15. Okay, so this was kind of like a pseudo word problem. Okay, are you ready for your first one? Too bad we're doing it anyways. All right. So I'm going to get out my highlighter because I like to highlight things as I'm reading them, so then I don't have to read them again. Okay. Suppose that the depth of water at a popular surfing spot varies from 3 feet to 11 feet depending on the time. Suppose that on Monday, high tide occurred at 6 a.m. and the next high tide occurred at 6 p.m. So that's our high tide. Find a sinusoidal function formula that represents the depth of the water as a function of the time in hours since midnight on Monday morning. Okay, so hours since midnight, that kind of like indicates that my y-axis is like the 0 hour mark. So I'm going to sketch this because I like sketching these things. So midnight is the 0 hour mark. Okay. And so one of the things I know is that the depth went from 3 feet to 11 feet. Okay. And high tide was at 6 a.m. So at 6 a.m., it would have been at that, since it's the high tide, it would have been at the 11 feet mark. And then the next high tide occurred at 6 p.m. So you've got your 12 noon, and then 6 p.m. would be like the 1800 hour mark. And that's when it hit its maximum again. So it went from, high tide at 6 a.m., 11 feet, high tide at 6 p.m., it was at 11 feet again. And at some point in between, it would have like reached its like minimum. Okay. So this is like what they've described, right? Now you can think like, okay, what was the tide, like water level at midnight? Or we can just use the sketch we have. Because like the sketch we have is pretty simple. Looking at it, I'm like, well, that would be cosine if this is like my starting point. It's not flipped, but I'm also not starting on that y-axis. I am starting to the right 6 units. So that means I do have that shift. For the amplitude and midline, remember, I know like the max was 11 and I know like the min was 3. So I can use these in my amplitude midline formulas. So my amplitude would be like 8 over 2, that's 4, and my midline would be 14 over 2, and that's 7. When it comes to the period, they told us it went from high tide to high tide, from 6 a.m. to 6 p.m. So like cosine completed itself one full cycle in 12 hours. So the period would be 12, and then the b value would be 2 pi divided by 12, and that's just simply pi over 6. So now I can put all these pieces together and I can write a function for the depth. So they want us to use d for depth. We're starting with our amplitude. This is not flipped, so positive 4 is how it starts. Next up, we have our trig function, which is cosine, followed by the b value of pi over 6. We do have that shift of right 6, so that's going to be t for time minus 6. And then lastly, we have the midline of 7. So the depth function, my particular depth function is d is equal to 4 times cosine of pi over 6 times the quantity t minus 6 plus 7. And that's because I started at that high tide at 6 a.m. That's why I have that shift and why I'm using cosine. Okay. So this whole unit on periodic functions started with the Ferris wheel, and here we are, we're at the end of this unit, and we are going to end it with the Ferris wheel. So I bring the Ferris wheel back to you for our last problem here. Okay, so let me get my highlighter out so I can get all the key info. The Ferris wheel shown makes one complete turn every 20 seconds. The rider's height above ground at any time can be modeled by a sinusoidal function. Find a formula for the rider's height. Okay, so there are some like other pieces here that we need to look at. We need to see that when you get on right here, you are already 8 feet off the ground. So what that means, if that's like your starting point, that's also your min, right? So we have a minimum value of 8. They are indicating that the Ferris wheel has a radius of 25, which means like the full diameter would be 50, right? Which means like what would be the maximum height at the very, very top of this thing? Yeah, we're looking at 58. be your maximum height. Okay. When it comes to sine versus cosine, if you are getting on the Ferris wheel right here at the bottom, what function is this? Yeah, it would be cosine because you're getting on at the bottom, the minimum, right? And since it's the minimum, that means it has been flipped. Okay. And there aren't going to be any shifts here because basically, like, you're getting on the Ferris wheel at a time of 0. Okay, and you're already 8 feet off the ground, and then your like height is going to increase until you reach your maximum height, and then you'll return, right? So this is kind of like what our graph is going to look like. So when it comes to amplitude and midline, I can use my max min formulas for that. The max is 58, the minimum is 8, which would mean the amplitude would be 50 divided by 2 is 25. And then the midline would be, let's see, what is that? 66 divided by 2, so 33. Identify the period. So they actually gave this to us. They said one complete turn happens every 20 seconds, right? So you'll return to the bottom after 20 seconds. So now I just need to calculate my value of b because, well, you know, they're not the same. So 2 pi divided by 20 is pi over 10. So we've done our full analysis, which means we're ready to write our height function. So the height of the passenger is going to be equal to, remember, we are starting at the bottom, so it's flipped. So I'm going to have a negative in front of my 25. Next up is my trig function of cosine, followed by my b value. There's no shift, so I'm just going to have my variable, and then I'm going to finish it off with my midline. So my height function looks like h equals negative 25 cosine of pi over 10 times t plus 33. And that's how you write a sinusoidal function for like a contextual situation. So like a sketch helps in seeing like what's my function, sine or cosine. When it comes to the big three of period, amplitude, and midline, use your max and mins to help you identify the amplitude and the midline. And then remember the period, do the math because the b value is different. The b value is equal to 2 pi divided by that period. And that's how Becker breaks it down.